Hey folks, welcome back. This is another example of graphing rational functions with only horizontal asymptotes. This example is a little bit more interesting because it has no zeros, that is no x-intercepts. So we're going to take a look at what that looks like exactly as we solve through these problems. Like I said, it's number 53 off of the homework if you're following along at home. So here we go. We're going to start off by factoring this out. Same thing we always do. So I'm going to turn this into r of x is equal to 3 times x squared plus 2 in the numerator. And pay close attention to this numerator here. It's going to do something nice and interesting for us in a few minutes. So the denominator is going to factor out into x minus 3 and x plus 1, just like that right there. All right, so now, as we always do, we're going to take a look and see if we can figure out what our zeros are by taking the numerator and setting the numerator equal to 0. Now, a lot of you might be tempted to try to factor this out right here, x squared plus 2. Well, as it turns out, we cannot factor this out any further. This is about as easy as this factor is going to get. So we're just going to set that entire thing equal to 0. Now, remember, when we set this numerator equal to 0, the only part that we really have to be concerned with is the x squared plus 2 portion, because I can always divide this 3 out, and anybody knows that 0 divided by 3 is just going to give us 0 anyway. So I'm going to take this portion right here, this x squared plus 2 equals 0. And I'm going to try to solve this for 0. Well, that's going to leave me with x squared is equal to negative 2. And I can take the square root of both sides, and that's going to leave me with x is equal to the square root of negative 2. This right here is a non-real answer. It's an imaginary number. And when we're dealing with zeros like this, we cannot have imaginary zeros for these types of rational functions, at least for what we're doing right now. So when you see this case here where you end up with a situation where this does not exist, there is no real 0 here, then you're not going to have any zeros in that numerator. So we can say that there are no zeros for this one. No zeros. Now, I suppose there could be a case where you did have a real 0 and a few non-real zeros, and that would be okay also. But as long as you know that if you end up with a factor that looks like this, x squared plus 2 equals 0, or x squared plus another number equals 0, well, just know that there's no way I can square a number and have it cancel out another positive number. All right, so we know that there are no zeros, so we can go ahead and try to figure out what our vertical asymptotes are going to be. And I do that by simply taking these two linear factors, setting them equal to 0, and solving them for x. So here we go. So vertical asymptotes are given by x equals positive 3 and x equals negative 1. So I have no zeros. I have two vertical asymptotes. I can go ahead and focus on trying to find my horizontal asymptotes, or my single horizontal asymptote. And we're going to do that by looking at our original function. So we see that our original function has degree 2 in the numerator and degree 2 in the denominator. And when the degree of the numerator is the same as the degree of the denominator, then what we're going to do is we're going to take the coefficient on each of those, and that's going to tell me where my horizontal asymptote is located. So I take the coefficient of the leading term of the numerator and divide it by the coefficient on the leading term of the denominator. So I end up having a horizontal asymptote at y equals 3 over 1. And that's where my horizontal asymptote is. So the final piece of the puzzle here is to figure out what the y-intercept is going to be. So y-intercept, and that's given by evaluating the function at 0. So we're going to take a look and see what r of 0 would be here. R of 0. That's going to be 6 This is going to cancel out, giving me 6 in the numerator. This will cancel out. This will cancel out, leaving me with -3 in the denominator. And if I have 6 over -3, that just means that r of o is equal to -2. So that tells me where my y-intercept is. Y-intercept at 0, -2. And now I have all the pieces of information that I need to create my information wave. So let's take a look at this info wave here. We're going to start off by making the same number line we always make when we're making an info wave. So take just a regular old-fashioned number line and lay it right across the top. There's that. And put a little 0 right in the middle, just so we know where our 0 point is. And if we look back at our notes here, and we can see that we have no zeros, so we don't have any real zeros. We're not going to cross the x-axis with our graph. And I have 2 vertical asymptotes, one at 3 and one at -1. So I'm going to go ahead and put those right on my graph. I have one at 3 and one at -1. So here is my vertical asymptote at 3. Here's my vertical asymptote at -1. I look at the leading coefficients on my graph here. 3 and 2, they're both positive. If they're both positive, that means we start up in the top right-hand side. Now, we're looking also to see if there's any multiplicity at all at any of these zeros or asymptotes. And we can see here that even though we have x squared, because it's x squared plus 2, that means that it doesn't have any multiplicity. If the squared had been on the outside of the factor, then we'd have some multiplicity. But since it's not, we're not even going to think about multiplicity here. So we're going to go right ahead and we're going to say, all right, I'm just going to cross, and I'm just going to cross over here. And there it is. So what exactly does our info wave tell us? Well, it tells us exactly this, that I'm positive, positive, positive. Anywhere that I'm to the left of -1, I'm negative, 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 all between -1 and +3. And then I end on a positive note on this side, on the right-hand side of 3. So let's go ahead and draw our coordinate axes down here. So we can start to graph our function. And draw it straight down there. And you don't have to line these up vertically. I just try to line them up a little bit so we can see what's happening between the info wave and the graph of my rational function. So we have our function here, and we don't have any zeros, but we do have 2 asymptotes, one at +3. I'm going to go ahead and make that my asymptote right there, and it's at +3. Here's what it looks like. Oh, let me use the right color. There we go. So asymptote there at +3, and we're going to have another asymptote down over here at -1. So let's go ahead and lay that right on in there. There's that. So asymptote here, asymptote here. I don't have any zeros, but I do have a horizontal asymptote. So let's go ahead and draw that horizontal asymptote in. And if you remember correctly, the horizontal asymptote happened at 3/1. So I'm just going to come up here to about 3. And you don't have to be really precise with this, but do label it so that we know exactly what's happening. And this is going to be our y equals 3. And the last piece that we have to throw on there is our y-intercept, which happens at 0, -2. So we're going to come right down over here. We're going to go, where's -2? Here's 0, -2, right down there. And that's my y-intercept. So now we can actually graph it out and see what this is going to look like when we do graph it out. As always, we're going to start right on our horizontal asymptote. And if we notice, it's positive and positive, and we are indeed above the x-axis, which is always a very nice reassuring sign that we're on the right track. Now, if I look at my info wave, I notice that when I'm on the left-hand side of -1 of this asymptote, I'm actually positive the whole way. So as I get close to this asymptote, I have to make a decision whether to go up or down. And in this case, the info wave, because it's positive, tells me that I have to go up. And similarly, between -1 and 3, I never cross the x-axis. So I have to stay down. I have to stay negative. So we still have to cross through our point of interest, but we do stay negative the whole way. There's that. And now we can come over here from this side and we can say, all right, I come in right along the asymptote and I have to stay positive the whole time. So right there, we go straight up and that's our graph. And as long as everything labeled, we'll be in good shape. And this problem is now done.